Nuclear energy. So nuclear fission is the process in which a heavy nucleus with a mass number greater than 200 splits into two smaller nuclei and one or two neutrons. Then those neutrons will hit other nuclei of other heavy atoms and cause them to undergo fission as well. And this releases a large amount of energy. Uranium is one element that does this. In the 1950s, they were considered low-cost, CO2-free alternatives. So nuclear energy was going to be the future of energy production. But then high operating costs, accidents, and public concerns about nuclear waste has made nuclear power controversial and halted production of new plants. So we kind of stopped building plants because they got expensive, there were accidents, etc. So how does a nuclear plant work? Well, it's very similar in ways to a coal-fired power plant. You have steam that is produced. That steam then is directed to a turbine, which turns the turbine and produces electricity. It's just how the steam is produced is significantly different. You have your reactor core, where the radioactive material is, and you have a liquid, usually like heavy water or something, that would actually flow through this and come into contact with the radioactive material and be heated up. And then that water would go through a coil in the boiler to actually heat up water that was pulled in from a second loop. So you actually have three loops of liquid here. You have the water that's in direct contact with the radioactive material, which then heats up water in a second loop, which is turned to steam and actually powers the turbine. Then you actually have a third loop of water here for cooling, where this is pumped in and used to cool down the reactor water here. So actually, the radioactive material is, three loops of water away from the actual environment. This is all contained inside a containment shell. And you have these control rods, which are lowered into or taken out of the reaction material here, the radioactive material, and either slows down or speeds up the reaction. So this is the basics of how a nuclear power plant works. But in the end, really, you're using the nuclear material to heat water to make steam to drive a turbine. So a few major nuclear disasters. We had 3 Mile Island in Pennsylvania. That was 1979. There was a stuck relief valve that allowed a large amount of coolant water to escape. There was no real major fallout from that, but it was a scary situation. You had Chernobyl in Ukraine in 1986. This occurred during a safety test to design procedures to keep cooling water flowing during a power outage. And in this case, the entire reactor melted down. There were fires at the plant. There was a large release of material, and actually this area of Ukraine is still not really habitable. And then in 2011, we had the Fukushima Daiichi power plant in Japan. And this was actually a power plant that was hit by a tsunami and actually caused a lot of damage at the plant and a lot of radioactive material to be released from that plant as well. So these major disasters kind of made people really rethink how safe nuclear power was. It's good for the environment in the sense that there's no CO2 released, but if you start releasing radioactive material, that creates a lot of other issues.